All right, by this stage in your calculus career, you're really building up the derivative rules, so let's add on some more. In fact, using trigonometric functions, let's add on 6 new rules. As you can tell from the title, these trigonometric derivatives rely on your memory. So for some of you, that's good news. For some of you, that's bad news. Basically, the chart you see in front of you, you have to memorize that. What it's saying is, you know that sine function that you're familiar with that does the old blah? Believe it or not, it's not even magic. That thing has a derivative of cosine. In other words, cosine is the formula that will give you the slope for sine at any x value that you care about. Kind of a bit freaky. So another way to look at this is the secant function. It's not very popular, you're not very familiar with it, but the formula for the slope of the secant function is secant of x times tangent of x. So these two trig functions multiplied together will give you the slope of that function. Very eerie stuff. How does all this stuff intertwine together? So you have to memorize this. I'm going to give you a little bit of a hint. In math, your nemesis is almost always subtraction or negative signs. So notice any trig function that begins with c, cosine, cosecant, cotangent, they have a negative on their derivative. Those are the only functions, trig functions, that have negatives on their derivatives. And most people say, I don't want to get a C for a grade. A C is a negative thing. A C is a negative thing. A C is a negative thing. The other thing I will alert you to is this. Tangent and cotangent both have derivatives that are squared. So this is the not so popular for high school students style of writing squared. Secant squared of x. If you don't like that, if that's going to mess you up, write it as secant of x squared. That's going to be a very popular eyeball adjustment when we learn about a very, very important rule coming up. But these are both legal, they're both interchangeable. You probably like this one better. All right, so there's not a lot to add to this. You just simply have to memorize that. But I'm going to show you two examples and see how this goes in action. Let's start with a product rule example. Okay, so I have tangent of x, cosine of x. When we were learning product rule, I said, well, we have to make up these somewhat easy functions because we don't know other rules. Well, now we're starting to learn other rules. So as I look at this, that's definitely product rule. So as long as I have the trig derivatives memorized, derivative of the first times the second plus the first times the derivative of the second. And I can rearrange that. And let me explain what's happening here. You see that cosine? When we took its derivative, remember cosine would have a negative sign for a derivative. That little negative sign can get lost in the shuffle. Plus this times this is like subtracting that thing. So that negative sign goes there. So just be aware, those negative signs can be pesky. And I'm going to show you one other pesky item. Brand new example. P of v equals 4 times secant of v. Now, when you have a coefficient, it does not have a variable. It's not a 4x, it's just a 4. A short and tidy rule is that coefficient will remain on your derivative. So I can kind of say, hey, what's the derivative of secant? The derivative of secant is secant tangent. The coefficient just remains. But for some reason, that does not stick in people's brains. So I'm going to show you a way you can figure that out if that wasn't sticking in your brain. OCD here. All right. Same exact problem, but now I'm looking at it through the lens of product rule. 4 times secant of v. You might not have thought of that as product rule, but it really is. So now watch what happens. The derivative of the first times the second, and the derivative of a 4 is a 0. That's sometimes so easy it's hard. I'm going to show you a reason why that is here in a little bit. The second part of the product rule plus the first times the derivative of the last. That got a little bit ugly there, but this is the derivative of secant is secant v tangent v. Well, this whole first part multiplies to 0, so it's 0 plus this thing. So my final answer is 4 secant of v tangent of v. It's exactly what we got over here. So if I use the product rule, that coefficient of 4 ends up being out in front. So go ahead and do that if you want, but I'll bet it's easier to say, hey, see that coefficient? It stays. You choose what you want. And finally, one little sidebar. Why is it, we may have gone over this already, but why is it that the derivative of 4 is a 0? I'm going to give you a way to think about it. It's a visual way. Go back to Algebra 1. I'm going to graph the line y equals 4. There it is, the line y equals 4. Hey, what's the slope of the line y equals 4? The slope is 0. Anywhere you go along there, the slope is 0. So that's the reason why the derivative of y equals 4 is 0. And that's the reason why when I did product rule here, that 4 became a 0. All right, the big picture, you gotta memorize those derivatives. Be careful with the negative sign on any trig function that starts with c, and don't let this squared thing throw you for a loop. Go ahead and rewrite it like that if you don't like it the other way. See ya.